So guys, welcome back to the YouTube channel. Today we are going to see the logic that we are going to use in order to solve this Leet Code problem, that is cameras. So I have, the previous video that I have uploaded is of, explanation of the same problem. So you can quickly go and check that out, that what the problem statement is trying to ask from us, what it is telling. So after that you can, come to the logic that how we are going to solve this particular problem. So in order to solve this problem, what logic we are going to apply is that we are going to create certain states. Okay, so if you are not under surveillance, you will return -1. Okay, if you have a camera, you're going to return 0. And if you are under surveillance, you're going to return 1. So these are basically the three cases that can be generated for any particular node. These are basically the three scenarios that it is going to face. Either it is under the surveillance by some other node, or it has a camera, or it is not under surveillance. Okay, apart from that, no other scenarios will be generated. So this is the thing. And now in order to store the minimum number of cameras, we are going to create a static variable minimum itself, that is going to hold the minimum number of cameras that we are going to require in order to cover this whole binary tree, or to take this whole binary tree under our surveillance. Okay, so where is my pointer basically? Okay, sorry. Now it is not. So this complete thing. Okay, so we are going to create a static variable minimum and we will initialize it to 0. Then we are going to increment it. So now we are going to see how these all things that I am talking about, we are going to utilize it. So basically, suppose this particular child node is not covered by any of the cameras, so it is going to return -1. Same for this child, -1. So this value will go to its parents. Now the parent will analyze, okay, both the children are not covered by any cameras, so it is my duty to install a camera right now. It is going to install a particular camera here, and while installing the camera, it will increment the minimum pointer as it holds the minimum number of cameras that is required. So it will increment it. So this minimum will become 1. Okay, this minimum is going to become 1, and at this very moment it will return 0. It will return 0, as 0 signifies that, okay, I have installed a camera, I have a camera right now. Okay, and similar for this case also, child will return -1 and -1, and then this data will go to the parent node. It will check that, okay, both the children do not have any camera. It's my duty. It will install a camera, increment the pointer, it will become 2 and return 0. So this 0 will go to its parent's node. So it will see, okay, both my children have camera right now, and so I don't require any camera. I don't require any camera for my surveillance, because the thing was that the constraint on the camera was that it is going to cover its parent itself and its immediate children. So that was the thing. So it will get it is getting covered, so it will return 1, as 1 signifies that you are under surveillance. So this is the whole logic that we are going to use in order to solve our particular problem. So we are going to call the left part and the right part separately, that we will see in the code itself. So hope you are getting that what I am trying to tell. Thank you. So basically I have structured a code little bit. I have just created a function that is minimum camera. Okay, that is going to return the minimum cameras that are required in order to take the complete binary tree under our surveillance. So we have created the minimum cameras. Now if root is equal to null, means nothing is there. So what we are going to return? That's the thing. We are going to return 1, as the 1 denotes that everything is covered. Let me show you this with an example. That suppose basically Basically nothing is there. No, this node also does not exist. So suppose this is our binary tree. Nothing is there. So everything is basically under our surveillance. So what we are going to return is 1. We are going to return 1. Okay, so that's what we have done. Now, so okay, if root is equal to null, we are going to return 1. And if root dot left is equal to null and root dot right is equal to null, what we are going to do is we are going to return -1. Why -1? Because -1 denotes that you are not covered. And if you are not covered, you are going to place a camera. Okay, so this also I will tell. Suppose a single node is there, nothing is in the left, nothing is in the right. So it will basically it will give -1 to tell that it is not under surveillance. Okay, so the thing was we need to take ourselves, our immediate children and our parents into our surveillance. So in this case, I am not into surveillance. So that's what this particular -1 tells us. Okay, now we will create some things called int left, which is going to be same thing minimum minimum camera root dot it will cover the left part of this tree and will generate int right it is going to take it is going to take it is going to take right part of the tree, that is root dot right. Now okay, so this is the thing. The thing is that suppose if left is equal to -1 or right is equal to -1 what we are going to do, we have discussed only that we are going to uh, uh, increase the counter. We're going to increase the counter. So what we are going to do is we're going to increase the counter, that is counter plus plus. Followed by we are going to return 0, which tells us that okay, I have in camera. Return 0. Okay, this thing I have done. Now we are going to use another if statement that will tell that okay, if left is equal to 0 or right is equal to 0 means either the left child or right child has camera, that then what you are going to return, you are going to return 1 and 1 tells that you are under surveillance. Okay, so we are going to return 1. Okay, if this both if that we have used, so means that suppose if you do not require a camera and you do not have a camera, these both things, neither you require a camera nor you have a camera, means you are under the surveillance of some other node. So then what we are going to do is the root will return -1 in order to tell that this particular node needs a camera. So what I'm telling, I will tell you with an example only. Suppose here is our parent node, these are two children's, and these children's are already under the surveillance by some other nodes. So neither these children require the camera and neither they have a camera. This is the condition. So the both if loops, no, these are telling the same thing. So neither these two children requires a camera, neither they have a camera. Then the parent will return -1 in order to tell that I need a camera right now in order to put myself under surveillance. Okay, so I hope you are getting it. So at the end we are going to return minus 1. Now we are going to drop this thing now, because I think what is the last loop? If statement. This if is covered, this will get covered at the last. This, okay. Why is it so? Okay, so I've done a mistake. I'm going to do this, and everything is done now. Okay. So now we have created our function. Now in the main this function, what we are going to do, we are going to call a particular function. So if minimum camera, we have passed the root is equal to minus 1. What it's going to do is it's going to increment the count plus plus, and we are going to at last we are going to return the count. I hope everything is good. One thing I was worrying about that I have not initialized the counter. So that is public int count equal to 0. So run this particular code. It is telling that return minus 1 state line number 21. Okay. And count plus plus executed. Count plus plus. Here is there. Space okay for that. Minimum camera line number 12 and line number 14. Quickly going to resolve this thing. Minimum capital line number 14. Why is it okay? So here also na minus 1. So it is getting accepted also. Let's quickly submit it. I think my net is not working properly. So because of certain network issue, it is taking so much time. So it will get submitted also. Okay, so it is getting accepted, beats 100% of the user. So okay, thank you.